Hi children, how are you all? Namaste to all of you and welcome to today's maths class. So what we were discussing in the previous class, that is the third chapter, playing with numbers. In that we studied about common factors and common multiples. Common factors, common multiples, prime factorization. Prime factorization. With that knowledge, we have solved some of the questions from exercise number 3.5 and we continue today the exercise number 3.5, question number 7. The product of three consecutive numbers. Product means the result which we get after multiplication of numbers. The result which we get after the multiplication of numbers is known as product of what? Consecutive numbers. Consecutive means successive numbers, one after the next, the immediate one. Three consecutive numbers is always divisible by 6. That product is divisible by 6. Verify this statement with the help of some examples. We will see whether it is divisible by 6 or not and we will verify with some of the examples. You see here, three consecutive numbers. 1. Next number is 2 and next number is 3. 1 into 2 into 3, 6. It is divisible by 6. 6 is divisible by 6. Do you agree? Yes. 6 ones are 6 and we get remainder 0. Next you take any three consecutive numbers. 2 into 3 into 4. 2 into 3, 6. 6 into 4, 6 fours are 24. 24 is also divisible by 6. You take some other numbers like this. 3 into 5 into 6 you take. 3 into 5. So 3 into 4 into 5 or otherwise you take 4 into 5 into 6. 4 into 5. 20. 20 into 6. 26 are 120. So 120 is also divisible by 6. So from this what we can see that yes, the product of three consecutive numbers, product of three consecutive numbers is always divisible by 6. Is always divisible by 6. It is always divisible by 6. Now, 12th question. I am the smallest number having 4 different prime factors. 4 different prime factors like 2, 3, 5, 7, 11, 13, 17, 19, etc. Can you find me which is that number? Is the smallest number. How do we get the smallest number? By multiplying the smallest prime factors. Which is the smallest prime factor? It is 2, then 3, then 5, then 7. So by multiplying these 4 prime factors, 4 different prime factors. So by multiplying the 4 smallest prime factor, that is small prime factors, that is 2 into 3 into 5 into 7. We will get what? 2, 3, 5, 7 are the prime numbers and the prime factors, the smaller ones. Now multiply 2 into 3, 6 into 5, 6 5s are 30, 30 into 7, 3 7s are 21, 210. So 210 is therefore 210 is the smallest number, but having 4 different prime factors. 210 is the smallest number having 4 different prime factors. What are the 4 different prime factors? 2, 3, 5 and 7. 2 into 3, 6. 6 into 5, 6 5s are 30. 30 is multiplied with 7. 7 zeros are 0. 7 3s are 21. 210 is the smallest number which is having 4 different prime factors. Is it clear, children? Yes. Now we will move to the highest common factor, HCF. How do we find the highest common factor? Now we will discuss highest common factor, that is HCF. H stands for highest, C stands for common, and F stands for factor. Highest common factor. And how do we find the highest common factor, that is HCF? Highest common factor is the of two or more than two numbers is the highest or the greatest of their common factors. Highest or the greatest of their common factors. We have seen in the previous class, we found the common factors. Some numbers are having only one is the common factor, and we call them as co-primes. And most of the numbers, they have more than one common factors are there. In that, among all those common factors, one common factor will be the highest or the greatest. That greatest or the highest common factor is the highest common factor, that is HCF. It is also known as greatest common divisor or GCD. Why? A factor is also a divisor, but factors will leave remainder 0. That's why they are known as factors. Factors are also a kind of divisors. That's why GCD means greatest common divisor. Now in this class we will going to study finding the GCD or HCF by writing common factors of the given numbers if they are small. Is one method. One method it is writing the factors of all the numbers, given numbers, and identifying the common factors. Third step it is identifying the highest common factor from the all the common factors of the given numbers. This is one method, that is writing all the factors of the given numbers and identifying the common factor. Among those common factors, identifying the greatest or the highest common factor. That is one method. The second method is the prime factorization method. Now let us discuss the first method by writing the common factors of the given numbers. So example we will discuss. Find the HCF of the following numbers. See here, we will take 6 and 18. 6 and 18. Then the B bit we will take 24, 32. 24, 32. See the first bit we have A bit 6 and 18. Factors of 6. Right, first step it is write the factors of all the numbers. Factors of 6. 1, 2, 3 and 6. 1, 2, 3 and 6. Factors of 18. Factors of 18. So factors of 18. 1, 2, 3, 6, 9 and 18. First step, write the common factors of all the numbers. Second step, identify the common factors. 1 is a common factor for both the numbers. 2 and we have 3 is there, and also we have 6 is there. Now which is the greatest common factor? The highest common factor? It is 6. 6 is the highest common factor. So here the common factors are what? Common factors of 6 and 18 is equals to 1, 2, 3 and 6. Which is the highest common factor? Yes, it is the 6. Therefore HCF of 6 and 18 is equals to what? It is the 6 itself. So like this we will write the common factors of the given numbers, and from that we will identify the common factors. Among all the common factors, take the greatest common factor or the highest common factor as the HCF. Next, give it 24, 32. 24, 32. Write factors of 24. Factors of 24. It is 1, 2, 3, 4, 6, 8, 12 and 24. 8, 12 and 24. Now, factors of 32. Factors of 32. 1, 2, then 4, 8, 16 and 32. Now the common factors. Common factors of 24 and 36. So identify the common factors. 1, 2, and we have 4 and we have 8. Do you find any other common factors? 3 is there, but we have no 3. 6, no 6. 12, no 12. 24, no 24. Is 1, 2, 4, 8 are the common factors. Now, therefore, the HCF of 24 and 32 is equals to 32 is equals to, which is the highest factor? Common factor is 8. Therefore, the HCF of 24 and 32 is 8. This is one method. That is, in this method what we will do? We will write all the factors of the given numbers and identify the common factors. In that we will take the greatest common factor as the HCF. Is it clear, children? Next we will discuss the prime factorization method to find the HCF of the numbers. Now we will find HCF using the prime factorization method. In this method what we will do? We will find the prime factors of all the given numbers. First step, find the prime factors of all the given numbers. Then identify the common prime factors. Identify the common prime factors. They may have only one common prime factor, or they may have more than one common prime factors. If they have only one common prime factor is there, that product itself will give you the prime factor itself will give you the HCF. If they have more than two prime factors are there, the product of all the common prime factors, the product of all the common prime factors will give us the HCF of the given numbers. So first step it is, we have to find the prime factors of the given numbers. Second step, we have to identify the common prime factors. Common prime factors. Third step, the product of all those common prime factors, we will get the what it is the HCF of the given numbers. Now, one example. Find the HCF of 20, 28 and 36 using the prime factorization method. Find the HCF of 20, 28 and 36. So the first step it is, write the prime factors of all the numbers. So 20 can be written as what? You can write 20 can be, it is 2 ones are 2, 2 zeros are 0, 2 fives are 10. So we got 5 as what it is? The last number, which is a prime number. Therefore 20 can be written as what? 2 into 5. 2 into 5. Next we have 28. So 28 is an even number, it is divisible by 2. 2 ones are 2, 2 minus 2 it is 0, then 8, 2 fours are 8, 8 minus 8 it is 0, 14, 2 sevens are 14, 7 we got, it is a prime number. Therefore 28 can be written as what? 2 into 7. 2 into 7. The last number it is 36. So 36 is an even number, it is divisible by 2. 2 1s are 2, 3 minus 2, 1 with 6, 16. 2 8s are 16. Again with 2, 2 9s are 18. Then 3 3s are 9. So 3 we got. Now 36 is equals to 2 into 2 into 3 into 3. Like this, we will write the prime factors of all the given numbers. This is the first step. Then identify the common prime factors. So here we have 2 is there, here we have 2 is there, and here we have 2 is there. For all the three numbers, one prime factor 2 is there. Identify again, we have here 2 is there, and here we have 2, and here we have 2 is there. So one more 2 is there as the common prime factor. Next here we have 5 is there, but nowhere is there in 5. And here we have 7, nowhere for other two numbers. And here we have 3 is there for 36, and it is not the factor for 28 and also 20. Now what is the prime factors which we have common prime factors? That is 2 into 2. Therefore the HCF of 20, 28 and 36 is equals to the product of all the common prime factors. The product of all the common prime factors, that is 2 into 2, which is equals to 4. So 4 is the HCF of 20, 28 and 36. Is it clear, children? What we did? First step, we found the prime factors of the given numbers. Then we identified the common factors. Then the HCF is the product of all the common prime factors. How many times it is there? 2 is there, 2 times common. That's why the product 2 into 2 it is 4, and 4 is the HCF of the numbers 20, 28 and 36. We will discuss a few questions from exercise number 3.6. Now we will discuss exercise number 3.6. First bit, find the HCF of the following numbers, that A, 18 and 48. So here I am going to use the prime factorization method. So prime factors of 18 it is 2 9s are 18 and it is 3 3s are 9. So 3 we got the, as the last number we got the prime number, so our prime factorization is over. Next it is 48. So write the prime factors for 48. 2 2s are 4, 4 minus 4 0, bring 8, 2 4s are 8, 8 minus 8 it is 0, then with 2, 2 1s are 2, 2 minus 2 is 0, 2 2s are 4, then with 2, 2 6 are 12, then with 2, 2 3s are 6. So again we got 3 as the last number, which is the prime number. Now write 18 as 2 into 3 into 3. So 48 it is 2 into 2 into 2 into 2 into 3. Now observe the common factors. 2 is one common factor, and here 3 is there, here also we have 3 is there, and here we have 3 is there, and there is no other 3. We have too many 2's other, but here there is no 2 as the common factor, only 1 2 is the common factor. So we discussed the previous sum, we have got common factor only 2, but here 2 different common factors we got 2 and 3. 2 and 3 are different common factors, common prime factors. In the previous problem, 2 is the only one prime factor we got, but it is repeated 2 times is there. Here 2 is one time and 3 is one time is there. Therefore, HCF of 18, 48 is equals to the product of 2 and 3. 2 into 3 it is 6. Now 6 is the HCF of 18 and 48. Now this is 18 and 60. See it. So write the prime factors of 18 and 16. So we wrote already for 18. 2 9s are 18 and 3 3s are 9. So similarly 16, the prime factors of 16, it is an even number, so it is divisible by 2. 2 3s are 6, 6 minus 6 0, bring 0, 2 zeros are 0. 2 1s are 2, 3 minus 2 it is 1, bring 0, 10, 2 5s are 10. 15 we got. It's an odd number. It is not divisible by 2. Next prime number is 3. With 3. 3 5s are 15. 3 5s are 15. 5 is the prime number. The last number we got prime number. Now 18 is equals to 2 into 3 into 3. 18 is equals to 2 into 3 into 3. And 60 is equals to 2 into 2 into 3 into 5. So we did first step, that is we note all the prime factors of the given numbers. Now identify the common factors. 2 is there 1 and we have 3 also is there one common factor. Therefore HCF of 18 and 60 is equals to what? The product of these two prime factors 2 into 3, that is equals to 6. Again in this case also we got the HCF as 6. Clear children? Right. We'll continue one more bit, that is G beta. 3 numbers are given here. Instead of 2, 3 numbers are given. 70, 105 and 175. Right. Now 70 is write the prime factors for 70. 2 3s are 6. 7 minus 6, 1. Bring 0, 10. 2 5s are 10. Now here we have 5 is in the units place. 5 7s are 35. So 7 is a prime number and the last number is a prime number. So our prime factorization is over. Next 105 we find the. So here we have 5 is in the units place, so it is divisible by 5. 5 2s are 10. 10 minus 10, 0. Then bring 5. 5 ones are 5. 21. Odd number, not divisible by 2. Check for 3. 2 plus 1, sum of the digits, it is 3. 3 is a multiple of 3. Therefore 21 is divisible by 3. 3 7s are 21. So 7 we got, it is a prime number, the last number. Next 175. So multiply with what? Divide with 5. 5 3s are 15. 17 minus 15, it is 2. Bring 5. 25. 5 5s are 25. Again we have 5 is in the units place. 5 7s are 35. 7 we got the last number. Now write the prime factors of 70 as 2 into 5 into 7. And for 105 it is 5 into 3 into 7. And for 175 it is 5 into 5 into 7. Now HCF of 70, 105 and 175 is equals to what it is. Identify the common factors. Here we have 2 is there and no 2 is the common factor. Here 5, 5 and 5 is there for 3 numbers. 5 is one common factor and we have 7 is there. 7 is common factor for all the 3 numbers. So here we have 2 common factors are there, that is 5 and 7. 5 7s are 35. So the HCF of 70, 105 and 175 is equals to 35. 35 is the HCF. Like this we will find the HCF of given numbers by using prime factorization method. What we will do here it is, we will write the prime factors of all the numbers, then we will identify the common prime factors, then we will take the product of those common prime factors as the HCF of the given numbers. So this is one method. Before we have studied one more method, that is by writing all the factors of the numbers and identifying the common factors. From that identifying the highest common factor. Third method also we have, it is the long division method. Long division method, which it is not there in our syllabus. Clear children how to find the HCF of the given numbers? So what we discussed today is mostly we discussed about the prime factorization in finding the highest common factor, that is HCF. finding HCF, that is highest common factor, or it is also known as greatest common divisor, that is GCD. We have studied two methods. One, it is prime factorization method. The other one, it is by writing all the factors and identifying the common factors. So I hope you understand today's concept. And your homework is exercise number 3.5, question number 8, question number 9 and question number 10. Exercise number 3.6, the first bit, find the HCF of the following numbers B, D, E, F, H and I. And question number 2, a small question is there, that this is your homework. And I hope you understand today's concept, what we discussed. In the next class, we will discuss about LCM, least common multiple. Least common multiple. The methods of finding LCM and its applications is there. That is, applications on LCM and HCF is there. That we will discuss in the next class. Is it clear, children? Yes. Thank you very much.